So in this video I'm going to show you the new program that I have done in order to make my life easier to classify the shapes of the TB bacteria. So as I'm going to show you, you're going to see a program that basically it's going to compute, it's going to do the segmentation with the first classifier that we have developed in previous logs. So if you remember, that was the basic classifier, and it actually did some segmentation on the image. So from there we just have as an output a binary image, and from there we're able to find the contours of the shapes that we have segmented, and from there we can just compute shape descriptors. Okay, so shape descriptors are a very interesting set of features that are able to discriminate shapes based on different features. Okay, so for example, in this program, as you can see, I'm highlighting this. We have a polygon approximation, which defines the number of segments that can be used to create our shape. We have compactness, eccentricity, convexity, aspect ratio, and other shape descriptors that you can find easily online. Even OpenCV has them. So the only one that you probably won't understand very well, and I don't understand it very well, it's the hue moments. Hue moments represent some sort of constants that describe one singular image, and so that's very useful because they can be described, they can be used for classifiers because they are a very solid shape descriptor. Okay, so based on that, we can compute a program. I have made this program, and it's going to make my life easier, as you will see. Okay, because it's going to be a whole journey to make this. As Andrew Ng says, whenever they make classifiers, they take a lot of time taking data, leveling the data. It takes a lot of time, but as I'm leveling the data by myself, you will see that it's not that easy. And besides, we need a database of at least 1,000 samples in order to have something good. Okay, but luckily I have a huge database, and by the way, this database that I have is from tuberculosis samples that are the best of the best in the country. Why is that? Because they belong to, they were made for the biggest TB detection laboratory in my country, which is from Hospital de Tórax se llama. That's the name of the hospital, and the samples are from there, so they are the best that I can get in order to make a classifier, and that's what we want, the state of the art of a set of features to compute a very good classifier. Okay, so the program, the first thing that it does is that it loads the logistic regression. I take the coefficients, I take the intercept or the bias term, and I compute a sigmoid in order to see its prediction. Okay, so it's going to classify a frame of 380 times 440 pixels, and I always forget because I make a lot of videos, because I make a lot of mistakes. But what I did is I increased the performance of the prediction, because I was using sklearn to make a classifier with the data that I had. But it was too slow. It took almost 18 seconds to make a classification of the image. To perform the segmentation. So I have taken the parameters, I have taken the pixel, and from there I just compute from scratch what is the prediction with this very easy and simple line of code. So we got a performance of 7 seconds over 21 seconds of classification. Okay, and now what it is doing. Okay, I said that it takes 7 seconds, and that's right, because my tests are done with that. You can take the code and verify that, but for some reason, whenever I just wipe this and then start it up, it does very slow. I guess it's because my Camtasia recorder is working. So as my computer is not that high performance, it's not able to do that. Okay, it's not able to do that fast as when I just have my processor dedicated to this thing. Okay, so this is the image that it reports. I can show you. here are the reported features of our first object that the segmented procedure has detected. And so we have this highlighted with or marked with a counter, with a green counter that is very thick. And actually there is another screen that you cannot see because it's in the other screen. It's in my laptop screen, and that magnifies this region of interest, so that you have the features and you have this region of interest, of course, scaled up, so that you can make a good labeling. Okay, so this is not a tuberculosis object, so we press N, and this whole classification goes to a file named, to a .csv file, and so that we can make a classifier later more easily. Okay, so in order to explain you a little bit of how these features work, here we have a very good example. Actually, this segmented object that we have detected over here is not a bacilli for these reasons. In the first place, the area of the object is incredibly small. You cannot expect to have tuberculosis bacteria with this size, because in reality you have that the bacilli has a length of 1 micrometer to 10 micrometers, and that scale, that compared to pixels is of oh my god, I forgot, it's of 50 to 80 pixels, but in this case this is 4, so it's more likely to be at some fuchsine debris. Okay, so that's not a bacilli object. We pass to the next one. You have the set of features right over here, and you have the segmented object, and you have the scale up frame, but that's not a bacteria. Now this is very interesting because, as the shape shows, this seems to be a bacteria, but it's not really. The polygon approximation of 7 also predicts that it is perhaps a tuberculosis bacilli. The area is equally in the historices that I was telling you. We have high eccentricity, so it shows that it is not a bacilli, but if you can see in the region of interest, which is increased, you detect that this is not a bacteria. Okay, so we're going to classify this as being another bacteria, and so we're going to have this as a negative sample for our classifier. So next one. We go to the next one, and actually this is not a bacteria, so it's better if we pass to something that it is a bacteria. Okay, so after finishing with the image, now it passes to another image, so it says classifying the pixels, and it's going to take a while to do that. While this is classifying, I'm going to explain you where have I taken these features from. Actually did it pretty fast, but let's talk a little bit about where I took the features from. Okay, this research is not new. It has been done by a few people. I have seen some Indians and some Europeans that did this job, 1 or 2 that I have found online, but I have found more than 8 papers from or reference or people that were close to some guy whose name was Forero, and I actually have one of his papers right over here from the lots of papers that I have for computer vision in this kind of stuff for bacteria. But the point is that he has worked with this for over 10 years. For over 10 years. And so he has gotten enough experience to determine which are the good features that work with this. Now, that work with tuberculosis classification. So as we are 10 years later from his research, now we have GPUs, we have machine learning, we have artificial intelligence, and some other techniques and technologies that allow us to make better predictors. We even have deep learning right now, so that's something that I want to implement. But the point is that I'm going to improve his research by using machine learning, and I guess I can make that very good. And so I'm able to provide a better classifier that just for someone who does this for a job, for a hobby. Okay, so continuing with this, let's go to one that is really really a bacteria. So this is the one, and as I can see in my region of interest frame, and I can see for the features that we have over here, the area of course is kind of small, but it's acceptable due to other things. For example, eccentricity, it's very high, so it's more likely not to be a circle but to be a curve, and we can define that by the polygon approximation, by the area, by the eccentricity, by the compactness, which is very low. And we have another which one, no, which was what I forgot. I had a very good reason for that. The convexity, which is false. It's not true. So convex forms have defect, have these points which defined. For example, this. If we make the contour of this is a convex hole, and here we have we have points in which we can make triangles, and so that's something that you see very often in debris or objects that are Fuchsine precipitations. And by the way, Fuchsine precipitations have not really been studied by these other papers. I don't know why, but they seem to be, or to appear very often, and to be confused with bacteria. But as I was saying, in this case, the features and my region of interest suggest that this is a bacteria, so I'm going to classify this as a bacteria. Okay, and so we continue working with this program. It's going to take me a couple of days, because as Andrew Ng says, it's not that easy to classify, to create a database. You have to level a lot of data unless you're using unsupervised learning. But we're going to be working with this, and I guess that's it for the video. And well, thank you.